Good afternoon, good evening, good morning from wherever you are joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor Sydney live stream event. Today I would like to welcome Bryn Lewis. Hi Bryn.
Hi.
Bryn is currently a self-employed contractor developing Windows Azure applications and IoT solutions for customers in New Zealand. With 30 plus years experience in the industry, Bryn has worked in a wide range of business domains, including mobile, radio, industrial, process control, professional services, online gambling, online retail travel, online lending, and financial services. So this session today will be approximately 60 minutes with about 10 to 15 minutes of those for questions. Do send us your questions throughout though in the Q&A section and we will try and answer as many as possible. And at the conclusion of today's session, I'll just share with you all a link to our feedback survey in that Q&A box as well. And this will also be uploaded to YouTube within the next 24 to 48 hours. So if you miss anything throughout today, you can refer to it on our YouTube channel, which I'll also share in the Q&A section. But for now, I'd like to hand the floor over to you, Bryn, to begin. So Bryn, over to you.
Hi all, my name is Bryn and I'm an MVP based out of Christchurch, New Zealand. To pay the bills, I work for a fintech on SaaS applications for managing foreign currency deals. But my side hustle, which brings me joy, is building IoT projects for education and business. Ignite Sydney was my last international trip, my last in-person conference. The Ruby Princess cruise ship was in Sydney Harbour and the news about COVID-19 was getting worse. Steve Kay and I were helping at the Meet the Experts area. My area is IoT and I always bring a couple of boxes of kit to tempt people to come and have a chat. A few years ago at Ignite Brisbane, one of the marketing people wasn't keen on how the gear was spread over the desks. It spoiled the clean lines of the booth. The person I was working for forgot to tell me until after the conference. I tend to get unusual questions and Ignite 2020 was more of the same. I got chatting with one customer about the applications of IoT in a commercial laundry. His company specialised in towels and linens for hotels. He wanted to keep track of how much stock each hotel was holding. He had found some RFID tags which would survive 200 washes, which was about the same as a sheet. He needed some devices in the truck, so I suggested using ruggedized Android handheld devices, which I'd used on another gig, to scan the RFID tags as the linen was delivered. Then using door arch sensors to scan the tags when the linen came back to the laundry for washing. When a sheet approaches the end of its serviceable life, it gets a yellow tint, so we talked about detecting this plus spots and tears with an ML model running on an Azure Iot Edge device. At another Ignite, I got chatting with a customer about a commercial IoT application. As the business conversation finished, she inquired about getting the position of the horse in an indoor arena where GPS didn't work. She wanted to track the position and orientation of the horse because often the horse isn't pointing in the direction it's moving. I suggested Decawave, which could position the horse within 10 centimetres and an MPU 6050 9 degrees of freedom IMU from TDK. There are Decawave developer kits available and they're very cool. They cost about $160 a pop. A 9 degrees of freedom IMU measures X, Y, and Z acceleration with an accelerometer, X, Y, and Z rotation with a gyroscope, and a 3-axis compass for heading, pitch, and roll. Steve and I had a couple of running jokes. The first was how bad my luggage must look in a scanner. This is a 40 mil length of pipe, a length of 40 mil pipe with end caps, which looks suspiciously like a pipe bomb, but it's actually a student project for measuring river levels. You cable tie it to a bridge pillar or a waratah in the ultrasonic ranger from a car bumper bottom measures the distance to the top of the water. But by far, the most popular question was, I have this, if you're Australian, holiday house, weekender, hobby farm, or if you're Kiwi, batch, lifestyle block, also known as a life sentence block, or if you're from south of the Waitaki River, a crib, and I would like to monitor. This is my wife's family batch. It's about an hour from Christchurch. The nearest good coffee is a 20-minute drive away in Cheviot, and cellular coverage is a 15-minute down the valley. As long as you're not on call, it's a great for a digital detox. I apologize in advance. My area of interest is where Azure Iot services interop with low power wireless devices. This is my specialisation, so I'm on the edge, I'm on the slope of enlightenment. This presentation is about how to acquire data and control actuators with other Microsoft products where I'm in the valley of despair. This is going to be a quick fire presentation, so I apologise in advance for taking liberties with your area of expertise. These were projects of mine a few years ago. Think of LoRa like a walkie-talkie radio. You talk and anyone nearby can listen in. I built a Windows 10 IoT Core Raspberry Pi field gateway for Azure IoT Hubs and Azure IoT Central. I had demo clients, had 24 demo clients for devices with all sorts of sensors. The device on the right is a solar-powered node for an orchard. It has 3 soil moisture sensors plus a temperature and humidity sensor. My implementation was not at all secure, but it was really easy for students to deploy and build clients for. Though beware, at $23 US, the 3 soil moisture sensors cost more than a Raspberry Pi with 4 gigs of RAM. Then, Windows 10 on IoT was canned a year ago. So I'm looking at porting to .NET Core running on Raspberry Pi OS. It was a product conversion gateway, which was fine for Azure IoT applications, but not so good for Azure IoT Central ones. I also have an MQTT client which talks to AWS ITO and half a dozen IoT and half a dozen other SaaS IoT services. Think of LoRaWAN as a cellular network for small, low-cost, low-power devices. All the gateways are constantly listening to all frequencies of the network. Uplink messages can be received by multiple gateways, so delivery is more robust, but the removal of duplicates messages is necessary. This also means, in contrast to a cellular network, that a LoRaWAN network doesn't notice or even care that the device is moving. It simply receives uplinks from the gateways nearest the device's current location. Most base stations have a GPS time source for synchronization. So with some basic maths, the network can also provide approximate location information. There are multiple vendors, and there are even a couple of open source options like the ThingStack and ChipStack. It uses unlicensed spectrum, so it's cheap to set up. In New Zealand, there are 2 nationwide networks which are operated by Spark and Cody. LoRaWAN was designed for long range. In an urban area, you get a couple of kilometers, maybe 5. In the country, you might get 10 to 15. It was designed for low power, so the batteries will last for years. There's a low cost per module and limited ongoing costs. You've got to appreciate that it's pretty low bandwidth, between 250 bits and 11 kilobits a second. You want to keep the payload as small as possible. This means you should not send JSON or plain text, but instead binary code your data. This is made really easy by the Cayenne low power payload format, which is natively supported by most networks. The interval between messages should be in the range of minutes, so be smart with your data. So where could you start? Something like an Use haze AT commands to change parameters. The battery is designed for up to 10 years operation. It'll work for 2 years if you're sending every 30 minutes. The QR code on the top is the device UI, the EUI, which can be used in conjunction with a cell phone application for in-field provisioning. The device supports external analog and digital inputs. It can even count pulses for water and power usage monitoring. To conserve power, the sensors can be powered up individually. Some sensors take a while to settle after being powered up, so there is a configurable delay between power on and measurement. Then, after a while, your IoT sensor addiction starts to get out of hand. We can monitor power consumption, smoke sensors, temperature sensors, a solar-powered GPS tracker, a presence detector, and even door switches. The Dragino L sensor on the bottom right is for monitoring doors. It costs about $70 a pop, and like many LoRaWAN devices, power consumption is key. It's powered by a CR2032 non-rechargeable battery. Sends 1 packet a day, just to say that it's still alive, and 1 for each open and close. In a good coverage area, it'll send about 12,000 packets. But in a bad coverage area, you most probably get about 1,300. Got global support for China, Europe, Indonesia, Korea, the US, Europe, Australia, and the rest of Asia. With such limited power and small bandwidth, reducing the size of the message is critical. The less time the transmitter is on, and the shorter the packets, the longer the batteries will last. The Cayenne low-power payload format is the most common. For example, a GPS position, latitude, longitude, and altitude is represented in about 9 bytes. The latitude and longitude are stored in 3 bytes each to save space, which leads to some interesting quantization issues. Like you can see in the image, the device is moving from node to node to node, but the odd random trip coverage isn't great. The Things network supports custom payload encoders and decoders written in JavaScript for specialized applications. For example, if your project needed more accurate positions or the data types weren't natively supported by it. The RAC 7258 on the left is designed for indoor use and is ideal for smart building applications and while you're building the app. The 7249 on the right is weatherproof and has many connectivity options, including via a cable, so it can support power over Ethernet. The RAC 7249 has 4 antennas. The longer one is for LoRaWAN, and the others are for Wi-Fi and 4G. The RAC 7258 also has a 4G option, which is good for backhaul from schools, where getting network access can be painful. Bonus feature if your weekender doesn't have cellular coverage, but the base station does. The gateway is running OpenWRT, so you could use it as a 4G connected wireless access point. Some important things. If your device is sitting on top of a hill, you're going to need power. You can buy a solar panel kit for about $400, which will power the device for up to 3 days if there's no sunshine. If it's sitting on top of a hill, you also want lightning arresters, because if lightning strikes your base station, there ain't going to be much left. They're about $30 a pop. One job I had, we had problems with people climbing the poles and stealing solar panels. So we put some of those stainless steel sleeves around the power poles just to keep possums off. We had to put longer ones so a human passed them. Once you've got a gateway sorted, you need a network to connect to. The Things network is a global LoRaWAN community-based network running open source software maintained by the Things Industries in Amsterdam. When I last looked, there were 170k global base stations, 150 countries. In New Zealand, there's just over 100, and in Oz, there's just over 900. I have a couple of nodes around home and several more at local schools in the place. It's like a cellular network for devices. And with the right setup, you can even roam globally. The Things network has deep integrations for AWS, IoT, All Things Talk, UbiDots, a few others. The sample Things network Azure integration is a couple of Azure functions, and it's really pretty lame. The sample Microsoft Azure integration for the Azure Iot Central is the Azure Iot Central device bridge. There is also a project for running a private instance of the Things stack on Azure. There is even an open source cross-platform implementation of LoRaWAN specification, which uses Azure IoT Hubs and IoT Edge. But beware, it only from memory only supports EU 868 and EU 433, or maybe US 915 band plans. I don't think it supports AS 923 and so forth, which are used in other countries. I had a look at the Azure Iot Central device bridge, but it wasn't what I wanted. Then had a go at building a Things Network version 2 gateway using an HTTP integration, which was a really, really dumb idea. Lots of tech. Azure Key Vault and storage queues, and storage queue trigger functions, the device provisioning service, Event Grid, Azure IoT Hubs, Azure Iot Central, basically a buzzword compliant technology demo. But I had a few snags. It was too complex to deploy and debug. I then had another go. I built a Things Network version 3 connector. It supports Azure IoT Hub, Azure Iot Central, and integrates with the device provisioning service. MQTT is used for uplink and downlink messaging. Device configuration is stored in the Things Network and accessed via the RESTful API. This is mainly because LoRaWAN setting. There are lots of LoRaWAN settings which I didn't want to replicate on my side. Using DPS, the LoRaWAN devices can automatically deprovision when the connector starts up. Though DPS is pretty much mandatory for Azure Iot Central. You can connect individual devices, but it's really painful. The application can be run as an Azure web job or on your desktop as a console app, which is really good for debugging. And being a web job, it's really simple to deploy. The configuration is a bit more complex, but now supports downlink messages in Azure Iot Central command. I'm currently working on digital twin definition language support, doing some SOAP testing and simplification. All you want is some graphs. Have a look at Azure Iot Central. It's no code, template-based setup. It's designed for lots of devices which are the same. It can be a bit painful if you've got lots of disparate devices. There are some specialnesses around the way that commands are sent to devices. The formatting of payloads is surprisingly complex and prescriptive. It's got 3 pricing tiers. If you're sending a few messages a day, 8 cents a device and 400 messages a month. Got devices sending a few messages an hour, it's 40 cents a device with a limit of 5K messages a month. You've got devices sending a message every few minutes, it's 70 cents a device and 30K messages a month. But for trials, there's also a free version which supports up to 5 devices for a week. Azure Iot Central rules let you monitor your devices in near real time, automatically invoke actions such as sending an email. Optionally, you can set up a time aggregation. I originally had problems with this when the temperature went out of band, and I got an email every 10 to 15 seconds telling me it was too hot. When you select the time aggregation, you must also select an aggregation type, such as a sum. With an aggregation, the rule triggers if the aggregate value of the telemetry data points and the time window meets the condition. For example, if you configure the rule when a temperature is above 25, and with an average time aggregation of 10 minutes, the rule triggers when the device reports an average temperature greater than 10 minutes calculated over a 10-minute interval. Once your devices are connected to an Azure IoT Hub, you can send commands to and process telemetry from devices. Message routing enables sending telemetry data from your Azure connected IoT devices to custom endpoints, such as blob storage, service bus queues, service bus topics, and event hubs. To configure custom message routing, you need to create routing queries to customize the routing of messages that match certain conditions. Once set up, the incoming data is automatically routed to the endpoints by the IoT hub. If a message doesn't match any of the defined routing queries, it is sent to the default endpoint. It's a 100 route limit, which seems arbitrary, but I have never ever had that many. I assume it's one of those limits that could be increased if you contact Azure support with a good story. Set up properties on. I set properties on the up messages in my Things Network Connect so it is easy to route them. The LoRaWAN devices tend to use different port numbers related to telemetry payloads. One of my devices has a GPS, which uses port 5, and some environmental sensors which use port 10, so I can route them to different applications. I can also route messages using the Things Network application ID. I'm looking at enriching the Azure IoT Hub messages with custom application and device attributes, which are from the Things Network configuration. The first time I updated my Azure IoT Hub routing configuration, it took more than 10 minutes to complete. I panicked. I went and made a coffee to calm down. Then I found a packet of biscuits that I'd hidden from the children. There were a few left. Then, by the time I got back, the IoT Hub had finally sorted itself out. Don't panic, just go for a walk. It'll be somewhere between 10 to 15 minutes, worst case. Azure Iot Central and a lot of the Azure IoT services only store telemetry data for a limited period. With Azure Iot Central, it's only 6 months. For post-processing and long-term trend analysis, I often stream data off to Azure IoT storage containers as a poor man's data lake. It can be in JSON or Avro for use with tooling like Hadoop. Azure Event Grid was introduced to make it easier to build event-based and serverless applications, I'm sure. Many Azure resources have baked-in support for publishing and subscribing to events from services like storage blobs and source groups. I built event handlers for webhooks to aggregate events from multiple systems. The schema for the messages is quite verbose, especially if, like me, you're coming from a LoRaWAN world where payloads are built and I'm counting bytes. But there are libraries to make it easier. At some stage, I really want to try hitching up Signal R so I can update a Webby client close to real time. Azure IoT Hub generates events which can be published to other applications. Device telemetry, device connected, device disconnected, device created, and device deleted. Device telemetry is the event used most often, and I often use it to stream events to Azure storage queues so I can see what's going on close to real time. The performance of device connected and device disconnected can be a bit patchy. The arrival time of the events depends on the protocol the devices use to connect to the Azure IoT Hub. With the AMQP, the Advanced Message Queuing Protocol, it can be 4 to 5 minutes before the disconnect event. With MQTT, it can be 5 to 10 seconds. With HTTP, it can be tens and tens of minutes. I've even used it with my legacy ARPI LoRa gateways to monitor uptime and connectivity. Azure IoT Central and other services natively support logic apps. I can route messages into service bus queues then process them with a logic app. Logic apps looked ideal for more complex processing and implementing business rules and notifications. I found it was great for things which were just a bit chunky for functions, Azure functions. I usually configure a service bus endpoint and launch the Logic Apps Designer. I must be stupid, but every time I use it, I feel like a newbie, just like GitHub. I find myself often throwing away my work and starting again from scratch. The number of connectors can be overwhelming, and I tend to stick to a selection of ones I'm familiar with. I assume it just takes time to get into the Logic App state of mind. I was going to include a slide or two about Power Automate, but the presentation was starting to get a bit long. FinTech company where I work to pay the bills uses Twilio. Setting up Twilio is pretty easy. It took a while to get the required content type for the dynamic content endpoint. The Verify MFA service is great. It was easy to integrate once I had pulled apart the sample code. It was another one of those samples where too much ceremony made it difficult to see what I was interested in. With apologies to Richard Hammond. It was when he was driving a bowl of wildcat round an quarry. I created a new Logic application, wired up Twilio, and within 10 minutes I had text messages on my mobile whenever my GHI electronics sent telemetry. It would have been first time in 5 minutes, but I forgot to start the Logic app. On the left is my Arduino sending telemetry over LoRaWAN using a rack 811 with no shield. On the screen capture, the right is a screen capture from my Nokia 7. I did burn through a lot of developer credits processing a number of messages that I while I was working on the Logic app. It's also difficult to delete them because they all came in from different numbers. This is the temperature and humidity in my garage over 24 hours. Many people have a love-hate relationship with Power BI. Power BI is one of my core incompetencies. In my gigs, I usually get the telemetry data and configuration to the edge of the data store, then knock up yet another hideous dashboard to show the telemetry is working. Then a highly trained Power BI professional configures visually appealing dashboards and reports for immensely satisfied users. After wiring up the sensors, configuring Power BI for testing always takes a couple of attempts, as I don't do it very often. Setting up consumer groups for the Event Hub built into your Azure IoT Hub is always one of those moments. It uses a consumer group for keeping track of what messages have been processed so that if anything restarts, it'll just pick up where it left off. Configuring the output usually works second time after I've got security sorted. A few times I've used Stream Analytics to move data around, but it feels like an awfully big hammer. I've been exploring it for spotting anomalies in data streams from little devices and aggregating values over short periods to show trends. There's so much functionality available. The SQL-like syntax is close enough but far enough away TSQL to cause pain. Now for a couple of diversions. On the left is a Arduino with a Wisno shield. Arduino comes from GHI Electronics. So if you want to get into IoT without having to do any C development or Python or run on a small footprint device, the tiny CLR is .NET compatible. It's baked into your Visual Studio. You can download applications in close to real time. You can debug I think you got pretty much all of the .NET functionality. You've got TLS, got interaction with SPI, I2C, the serial peripheral interface, and the integrated circuit bus serial connections. On the right is a .NET Nano Framework device. It's another WIS-Node shield. The WIS-Node, the Nano Framework is pretty cool. It's an open source project, and the people who've been building it have put in an awesome amount of effort. In the last week or so, it's gained support for generics, which is pretty amazing considering it'll run on an ARM S7 processor and a couple of 100K of flash and RAM. An old boss of mine was adamant that if a problem couldn't be solved with SQL, T-SQL, Microsoft SQL Server, it wasn't worth solving. To the extent that in a meeting, he wouldn't fire up Excel or use a calculator. He would be adding up numbers in a SQL Server Management Studio interactive query window. This nasty application takes the things network decoded sensor values and maps the payloads to user-created stored procedures. I'm not proud of this, but it's a quick and dirty way to get telemetry data into a store, which is easy to query and can be used as a data source for other tools like ML.NET, OLAP, and analysis services. So, if there's no NBN at your place, in my best hosty voice, in the unlikely event there is no NBN at your place, there are some options. Find a Raspberry Pi 3 and use one of my LoRa HTTP or MQTT gateways to talk to a local server. The big rack gateways have a built-in MQTT client, and you could build an MQTT broker with MQTT net. I'm thinking about giving this a go. You could even run a local LoRaWAN network using the Things stack or Chirp stack. If you're in the right area, you could use the Azure Iot LoRaWAN starter kit, as long as you're in Europe or America. For the duration of this presentation, I had a really bad echo. Echo is basically about a slide behind in my deck, and it's really thrown out my timing. So, has anyone got any questions? If you want to contact me, my blog is blog.devmobile.co.nz. Talk a lot about education and IoT. On GitHub, I've got 70 odd projects, and you'll get to laugh at the warts and all history as I figured things out.
Thanks,
Tweet
Bryn.
at Kiwi Bryn, and people can track my progress and little successes. If you want to email me, bryn.lewis@devmobile.co.nz. There can be a bit of a delay, but don't worry.
Thanks, Bryn. Sorry to hear about that delay. We haven't heard anything from our end, so it might just be something with your mic on your end. But from our end, we've heard you perfectly clear, and it's been a great presentation, so thank you. We haven't actually had any questions come through at the moment, so it sounds like you've answered everything in your presentation, but we will give people a couple of minutes to ask anything. In the meantime, I'll just put a link to the survey in that Q&A section, so if everyone can fill that out if they have some time, that would be great. I'm also going to put a link to just any of our other upcoming events online for our Sydney Reactor page. I'll just pop that in the Q&A section as well. Bryn, did you have anything else you'd like to add? Okay, I'm also going to put a link to the Learn module in there as well, which was also on the main event page So just popping that in there now. Seems like we're having some issues with delays and feedback from Bryn's side, and then a delay on my end. So we'll give it a couple more minutes for questions, and then we'll end. Okay, I see someone that was asking again about the question about YouTube. So we have answered that question there. So this recording will be uploaded to YouTube within the next 24 to 48 hours. And I've just put that link in the Q&A section as well for the YouTube channel. So please visit that YouTube channel in the coming days and you'll see the on-demand version there. Otherwise, we haven't had any questions come through. So I just wanted to say thank you to Bryn for joining us today and speaking. And thank you to everybody else for coming and joining us today, wherever you are joining us from. Have a good rest of your day, your night, your morning, and thank you for joining the Microsoft Reactor Sydney for another live stream event, and we will see you next time. Thank you, and thank you to Bryn.